Okay, welcome to the Anthropic principle. Sorry, a little technical glitch there at the beginning. A strange principle that involves everything from you to the universe, but I'll explain that today in Physics X, Extraordinary Concepts in Physics, where you can find little snippets on the web about really cool physics concepts without having to get too deep into the math. So we'll jump into the Anthropic principle with one of the things I like to do a lot, which is ask a question which requires some medium amount of thought. Is it a coincidence that all physical constants like G, E, and H, I guess this could be C, this could be the charge on the electron, are just that needed for life to develop? So G would be the gravitational constant, H would be Planck's constant tied into quantum mechanics, E would be charge on the electron, throw in C if you're feeling good, speed of light. Is it a coincidence that they are just the way they are? Yes, we sure are lucky. No, it has to be this way. Or maybe a little bit. So think about that. Grow old and eventually click the play button. Okay, let's clear those. Okay, you're much older now. The answer is debatable and is at the root of the Anthropic principle. Strangely enough, the title of this lecture. There is a consensus that only those universes with life-enabling constants can observe those constants. So for instance, let's say our universe had a really much greater value of G, the gravitational constant. Then let's say our universe was closed. Our universe would have then had a bang and would have just been really hot, thick soup of particles, and then would have collapsed back into a big crunch soon thereafter, without there being time for atoms, molecules, stars, galaxies, and people to develop. So far as we know, there would be nobody to ask the question, nobody to contemplate the universe. Therefore, life could not develop in that universe. Therefore, we don't see that universe. We see the universes for which the right constants for life to develop have existed. So this was first coined by Carter in '73, and actually was responding to the Copernican principle that, even the perfect cosmological principle, that all the universe is the same everywhere at all times. He said, no, we're lucky. Okay. Let's see if I can get to the next slide. Yes. Okay. Is it a coincidence that you are seeing this information on a computer screen? And yes, if you're in this lecture, you're seeing it on a computer screen too. Yes, you could have seen this on paper. Or no, this is an analog of the Anthropic principle. So you can whistle Jeopardy music to yourself. This should only take you a few years as opposed to the decades that it took you to contemplate the previous question. So this is my own version. I think this is an analog to the Anthropic principle. And the number of times a paper copy is seen will be much less, I would estimate, than this question, as you're seeing here, would be seen on a computer screen. Say it's 100 to 1. Then regardless of the amount of paper and the number of computer screens in the world, only those viewing this slide are relevant. So there might be a lot more pieces of paper in the world. And you say, oh, just given that, since there's more pieces of paper than computer screens, then you're more likely to read this on a computer screen. Yes, but this lecture right now exists primarily on computer screens. So you're more likely to be seeing it then. So again, the statistics are skewed to what's possible. And it's sort of a version of the Anthropic principle. And now comes something I've made up called the personal Anthropic principle. Is it a coincidence that you yourself are contemplating the Anthropic principle? Is that a coincidence? With all the billions of people, with all the life forms and computer forms, what chance is it that you yourself would be contemplating the Anthropic principle? What a coincidence that you yourself are contemplating it now. Is that a big coincidence? Possibly not. It's tied into the same kind of questions that pervade the Anthropic principle. So there's other ways of thinking about it. There's other varieties of the Anthropic principle. One is the unique universes, so that some physical theory of everything, TOE, can explain everything. If we understood the theory of everything, we would understand how it enables life. So maybe that says that there's only one set of constants that could exist. There's only one G that can exist in the universe. There's only one C. There's only one H. That's just the way it is. And it just so happens that it enables life. Those other ones, they don't exist. They never have, never will. As you can see, this is somewhat tied into the multiverse lecture that I gave recently. Wheeler, John Archibald Wheeler, came up with what's called the participatory anthropic principle, which says only universes with the capacity for consciousness can exist. So without debating, we can debate what consciousness means. This can become theological. A theist might claim that God created the universe to be the way it is. The multiverse hypothesis I just mentioned says that all possible universes exist, but only those universes that develop brains, like ours, can observe their own universe. So there are different ways of looking at things. To the nearest I can tell, neither is provable or disprovable. They make for fun debates, or sometimes not fun debates, and different textbooks. Here's my view. My view of the anthropic principle is somewhat different from my view of the multiverses. Invoking the anthropic principle, I think, is a good thing because it's a scientific attempt to include relevant information in statistical arguments. It is the physical equivalent of including priors in what's called Bayesian statistics, which you can look up, or taking a better inventory of the number of fair trials in frequency statistics. So it's actually an attempt to make a more scientific argument by including the anthropic principle by saying, no, these things couldn't see. These trials don't count in our statistics. These other trials, they do count. Therefore, I would consider that the anthropic principle is not good science. However, I consider it to be at least an attempt at good science, to include these priors, these chances that we could see ourselves, lead to better estimates of what the universe are like, in my view, maybe not perfect estimates, than not including them. Okay, now we get into something that's a little bit stranger. This is some of the strangest things. There are actually papers published on this, on the Boltzmann brain paradox. So first I will define what a Boltzmann brain is. It is a random fluctuation that develops into a universe-observing, self-aware brain. So let's say you had a universe out there. It was just your standard universe. It had hot and cold particles. It had randomness in it. Well, some parts of the universe would by chance, become somewhat more ordered. And since entropy is conserved, other parts of the universe would be much less ordered. So possibly some of those could become so ordered that you would get a brain, maybe like our brains. Well, one of the paradoxes is if entropy and disorder always increase, why do we observe such order in the universe? Well, the Boltzmann brain answer to that is we only are observing a very small part of the universe. And there's lots more disorder elsewhere in the universe. We just happen to luck onto part of the universe that's highly ordered. But we paid for it in other parts of the universe. So this can get stranger. Hold on to it. Our existence in such an ordered universe would seem to be highly improbable in a sufficiently vast universe where many Boltzmann brains could randomly pop into existence and observe a much less ordered universe. So we'll get into that a little bit more. First, a picture of Boltzmann. This is Boltzmann's actual head, a bust of it anyway. This is what it looked like. He was a famous physicist in many ways. Did a lot to do with thermodynamics and statistical mechanics. Here's something that's relevant to his laws. And so his actual brain was in the model that was there. Not in the model, in the actual person. That has since died. Which brings us to the question, which is more likely? At the root of the Boltzmann brain paradox. Is it likely that our brains developed alongside many other brains in this large universe? Because there seems to be other brains around us. Or is it more likely that your single brain developed with false memories and only the impression that many other brains exist? So, you know that person you call mom? No, she doesn't really exist. She doesn't have a brain. It's only your brain that exists. Your brain tells you that your mom existed, but you really can't prove that. Also your friends. This brings us to, this is the strangest one, strangest lecture yet, simulated reality. Is it possible to distinguish between a sophisticated computer simulation and reality? And this is given a slightly different name, the brain in a vat paradox, and philosophers debate this too. How is it that you really know that you're a person dealing with other people? How do you know you're not part of a vast computer simulation? Or in my case, not so vast computer simulation. For all we know, we might be living in a computer simulation, and the science fiction people have caught wind of this, and they've made movies like The Matrix, where things like this happen. Except in that case, they sort of broke out of their computer simulation. There were actual brains in that case, and they broke out of it into the real world. But we don't even have to have a brain. All you need to have is a computer box. Your brain could be a computer box. You don't really know anything outside your brain. How do you know things outside your brain exist? Theoretically, all your eyes, all the photons you see, that could be simulated. All the sounds you hear, all the touch you feel, it can all be simulated. How do you really know that it doesn't exist that way? So in the Boltzmann computer analog of this, multiple computer simulations might be easier to run than brains are to make. So how do we know? Let's look back to the anthropic principle and creating things. How hard is it to create a computer that can make you think you're you? Is that harder than creating you? It might be that it's much easier for universes to come up with simple computers that can run simulations that you think you're you than it is to come up with you yourself, because you might think you're very complicated. Roger Penrose, came up with a caveat that the human mind is too quantum mechanical to be simulated on a conventional computer. But that might just push it back another level, and there might just need to be quantum computers that run the human or the brain simulations. So, as I said, this is some of the strangest stuff around. Besides the anthropic principle being useful in quantifying statistics, debates as to whether we're part of computer programs that are simulated reality might not be easily testable. But they're a lot of fun to debate. And so at the end of this, I assume that you will go off and debate this with your friends. And I will see you next time. Physics X. Bye. With life-enabling constants can observe those constants. So for instance, let's say our universe had a really much greater value of g, the gravitational constant. Then let's say our universe was closed. Our universe would have then had a bang and would have just been really hot, thick soup of particles, and then would have collapsed back into a big crunch. Okay, welcome to the anthropic principle. Sorry, a little technical glitch there at the beginning. A strange principle that involves everything from you to the universe, but I'll explain that. This could be C. This could be the charge on the electron. Are just that needed for life to develop. So G would be the gravitational constant. H would be Planck's constant tied into quantum mechanics. E would be charge on the electron. Throw in C if you're feeling good, speed of light. Is it a coincidence that they are just the way they are? Yes, we sure are lucky. No, it has to be this way. Today, in Physics X, Extraordinary Concepts in Physics, where you can find little snippets on the web about really cool physics concepts without having to get too deep into the math. So we'll jump into the anthropic principle with one of the things I like to do a lot, which is ask a question, which requires some medium amount of thought. Is it a coincidence that all physical constants like G, E, and H, or maybe a little bit, so think about that, grow old and eventually click the play button? Okay, let's clear those. Okay, you're much older now. The answer is debatable and is at the root of the anthropic principle. Strangely enough, the title of this lecture. There is a consensus that only those universes